On the last section of notes, we focused on the different types of quadrilaterals. One of the types were parallelograms. And the main characteristics of the parallelogram was that it was a shape that had two pairs of parallel sides. Now we're going to look a little bit more deeply into parallelograms and the different characteristics and properties of them and solve some algebraic expressions based on what we know about the parallelograms. There's three different theorems we're going to look at. First, theorem 1 states that opposite sides of a parallelogram are congruent. So here I have illustrated a parallelogram, and of course we know it's a parallelogram because our opposite sides are parallel. And I've given the two side links here some values, so 3x minus 15 and 2x plus 3. So if this was a parallelogram like a rectangle, for example, I know in a rectangle that opposite sides are congruent, so I can solve for my value of x here by just doing basic algebra. I can go through and subtract 2x from both sides, which leaves me with x minus 15 equals 3. So I know now my x value is 18, because 18 minus 15 is what gives me 3. So x would equal 18. So you should be able to solve problems on parallelograms where you set the sides congruent to one another. Now theorem 2 discusses the angle values. So on theorem 2 it states that the opposite angles of a parallelogram are congruent. So the opposite angles here in my parallelogram are equal, and I've set up the equation to state that they are equal. Now the other part of this that they don't have written down as a theorem is that if these opposite angles are equal, so let's say that we solved for y, we did whatever, and we figured out that these were 100-degree angles. So combined I have 200 degrees. These angles here are also equal, and let's see, I have 160 degrees left, and if I split that in half I get 80 and 80. So that means that this would be an 80-degree angle and 80-degree angle, and these would be supplementary to each other. These would add up to be 180 degrees. So another part of this theorem that's not written down is that these consecutive angles, and by consecutive I mean if this is angle 1, it's consecutive with angle 2, or here with angle 3. But consecutive angles are going to be supplementary to one another. But if I'm here solving for y or solving for these angle measurements, I'd again, the opposite angles are congruent, so I'd again go ahead and set the two values equal to each other and do my algebra to solve for my value of y. So 37 is equal to 3y plus 4. I'm going to rewrite the equation over here. 37 equals 3y plus 4. I'll subtract 4 to eliminate 4. Again, my whole concept here is to isolate y. So what value times 3 equals 33? 11. So the y value here would be 11. Now if they ask you to solve for the angle measurements, you can then plug 11 in for y. 11 times 6 is 66, plus 4 is 70, so these would be 70-degree angles. Now, yes, the drawing is not to scale, so don't always assume what the actual angles are. Theorem 3 states that the diagonals of a parallelogram bisect each other. We've heard that word bisect before, especially recently with our section on perpendicular bisectors. So not only are we creating perpendicular lines, but we're also bisecting. So here I have a set of diagonal lines that are going through my parallelogram, and they are dividing themselves in half. Because this whole theorem states that the diagonals of a parallelogram bisect each other. So if they're bisecting each other, I can state that A is equal to B plus 2, and I can also state that B plus 10 is equal to 2A minus 8. But I have a little bit of a problem here because each of my equations have two different variables, an A and a B. So we're going to have to use substitution to figure out my values for A and for B. So already here on the left, I know that A is equal to B plus 2. So what I'm going to do, I'll call this equation 1 in this equation 2. I'm going to take what I know from equation 1, a equaling b plus 2, and apply it to equation 2. So I'm going to go ahead and say b plus 10 equals, and now instead of saying 2 times a, I'm going to say 2 times b plus 2. And then minus 18. So I'll go through and I will distribute, and eventually I will come up with an actual value for b. So what I'm going to do, I'll go ahead and do the 4 minus 18 first. 4 minus 18, negative 14. And I'm going to add 14 and subtract b. So that eliminates the 14s over here and eliminates the b's from this side. And so I know my b value is going to equal 24. So now that I know my b value is going to be 24, I can stick it back over here into the equation 1, where b is 24, and find that a is 26. b is 24, and a is 26. So you can kind of check things out too. If these are bisecting each other, a is 26, this side is 24 plus 2, so those are both 26. Here I have 2 times 26, which is 52, minus 8 is 44. So if I do, 2 times, so then I have my b value, which is 24 plus 10, which would be 34. Okay, so I'm going through and I can figure out that these actually do bisect each other. So we now found our values for a and found our value for b. Okay, on the back here, I have written down 2 separate problems that are in the book, but I've written them down for you so you don't have to get your book out. But it is on page 316 here. And it's numbers 47 and 23. Now 47 is a substitution problem just like what we did before. Okay, and on 23, we have these values of a, b, and c. And it says they're all on the coordinate plane. And what would be point E if ABEC was a parallelogram? Now I want you to do this and bring it to class on Friday. But remember that we're going in a certain order. So if I was to create this parallelogram ABEC, I'd want to be able to, this is just an example, not even close to being using those coordinates, but I should be able to read it A, B, E, C in that order. Not A, B, E, C here, but actually A, B, E, C in that order. So that should tell you, because right now you're thinking, oh, it's just the 4th point. Yes, but I want it to be A, B, and then some point, and then C. So figure out what that other point would be. And remember, with parallelograms, what we're focusing on are the slopes. Because if I know that I have opposite sides that are parallel, then my slopes are the same. So I'm looking for the slopes to be the same between AB and between EC. So go through and figure out if you can figure if what that point E would be for that coordinate on ABEC. And then on 47, this problem up here, I just want you to do a little practice of solving there. And that's how we'll begin class on Friday. So this is your notes on parallelograms. You should have done now quadrilaterals in general, and now we focus on parallelograms. Monday we will start looking at special parallelograms.